So, welcome to today's class. Today, we want to see the process of building an ensemble learning technique that we talked about yesterday theoretically. So, like we said, we talked about boosting, and the first boosting type that we looked at was the AdaBoost, and we said this is a tree-based methodology where each consecutive base learner assigns greater weight to the observations incorrectly predicted by the preceding learner, and it's a tree-based, meaning mostly we use decision trees. So let's go back and see how it's implemented inside this. So, like I promised, I went ahead and actually tried and found a banking fraud dataset, which we are going to implement boosting as far as fraud detection is concerned. So we just import the normal models and modules, the trends, the split, and also the grid search CV, the standard scalar. We also have the AdaBoost classifier, the gradient boosting classifier, and the voting classifier. Now, when it comes to these classifiers, already they have been built from scratch. Ours is just to use them to train our data. But already they have been built from scratch by by the data scientists at Skyline. For example, AdaBoost has been built using decision trees, and voting classifier has been built using random forest. Same to gradient boosting decision trees. Now we are also importing other SK other individual models like decision tree classifier, especially if we may need them later for stacking or blending purposes. We are also importing logistic regression. We are also importing the accuracy score and all other metrics that are used to evaluate a supervised learning model, a classification task that is. Then XGB classifier is imported very different uh, from a very different framework called XGBoost. It's a very large framework actually. You ought to install it inside the virtual environment. And like we said, it is actually fast because when you install it, it comes with NVIDIA components. So NVIDIA for Linux components, which brings its total. It's around half a GB. That is, it's a large one. It's a larger one. That is. Then we also import the stacking classifier, the job lib, and the logging and the date time. We import the time from date time. Maybe if you want to work with date components and everything. As we started before, we started by setting up logging, and we just need the basic information. Then random seed for reproducibility, import our data set, pre-process our data set by changing to numeric what ought to be changed. Also filling the null values. Remember that machine learning is actually very sensitive to null values. We also drop the unwanted features or columns like the customer ID. Then we change all the categorical features to list, and from the categorical features we remove chan because that is our response variable, so that we leave others as the independent or independent variables. Then we get dummies, and I think we've been thinking about this, so I'm not going to repeat much of that. Next, we split our data set. Of course, just to be sure, we had dropped expert, but just to be sure, we just dropped churn to ensure that the X variables are not made up of churn. And also define Y as the churn itself. Then we split the data set in 80-20 and confirm that by logging the information. Churn data split, 5634 training and 1409. Notice the use of f-string in Python and also the use of curly braces alongside f-string. Then Python's inbuilt functions like length, which is actually giving us the length, the number of rows that X-string is going to have. Then we scale the features accordingly, especially for other, if we want to use other models like blending and stacking meta learners, we need to scale the features. So our first model is AdaBoost. Yeah. Before we understand this AdaBoost, let's go back to the notes, and that's what I said we will be doing. We said that adaptive boosting is a tree-based boosting methodology where each consecutive based learner assigns greater weight to the observations incorrectly predicted by the preceding learner. And the preceding learner is mostly considered to be the decision tree. Even the current learner is decision tree. So the first decision tree gives us the results. Then if we get wrong predictions, then the second decision tree model is going to assign greater weight to the wrong predictions. So the AdaBoost builds its first tree on training data that gives equal weight to each observation. That is the first training. Then the algorithm evaluates which observations were incorrectly predicted by this first tree. It increases the weight, and the process repeats until either tree makes a perfect prediction or the ensemble reaches the maximum. When you come back to this, the AdaBoost classifier has been pre-built to ensure that first of all we need to start from the decision tree as we climb the ladder. So look at that. Estimator is any. So in our case, estimator is the decision tree classifier with the maximum depth of 1, meaning in the first level of implementing AdaBoost, decision tree should only be split once. That is, yeah, because the other split will happen again. AdaBoost classifier in itself has been developed in such a way that if you had indicated estimator to be decision tree, is going to build it over and over again until it gets the result. And that's what you see CV is equals 5. So we are trying with 5 to see if we are going to get the best result with CV is equals to 5. Others, of course, AdaBoost parameters are, of course, what we call the parameters, which, if you don't know what they are doing, it's recommended that you leave them as default. When you train them, AdaGrid.fit X10 and Y10, another model, you find the best estimator, then you predict using X-test. Now, when you evaluate them, you realize that the AdaBoost is 0.8055. And I said we were going to do this to, and learning rate is 1 and number of estimators are 100. So we are going to do this to compare it with decision tree classifier and see the result for decision tree classifier. You see, it was 0.7871. So it means it has actually increased even if it's 0.2. Second, are we together up to that point? Second model is gradient boosting. We go back to gradient boosting. Gradient boosting is different from adaptive boosting because instead of assigning weights to incorrect predictions, each base learner in the sequence is built to predict the residual errors of the model that preceded it. So in short, it focuses more on errors. Let's see how that's done. Gradient boosting parameters, the number of estimators can be chosen from a list of 100 and 200. It is going to choose 1. Of course, we're going to use grid search to ensure that iteration works the way you want. Then learning rate 0.05 and 0.1, then maximum depth between 3 and 5. So the grid search CV is going to start 100, 0.053, 100, 0.13, again 200, or 100, 0.055. So you can imagine, at the end of the day, it must iterate through everything, then find the best estimator, and that's what we are doing with this method here. So this SCB gradient boosting classifier, of course, all this information that we just read here has been developed inside gradient boosting classifier, and we said gradient boosting classifier basically is also a tree-based model. So we use in the first, as a base learner, we use decision tree, then we get predictions. Then the second decision tree model is going to focus on residuals rather than the predicted values themselves. So at the end of the day, that's the information that's inside this classifier. So we just reuse it, and when you evaluate it, it's 79.91. So what do you compare with gradient boost, AdaBoost? AdaBoost more accurate, correct. And but again, if you compare it with the single decision tree model, it works best for the single decision tree model. You might also want to compare it with the random forest classifier. Remember, random forest is also an ensemble learning, bugging. So between them, let's see which one works best than the other. Random forest is 0.806. So random forest is more accurate than AdaBoost or gradient boost, sorry. Yes. The next one now is XGBoost classifier. First of all, like I said, the only single source of truth is this place called XGBoost documentation. This is an optimized distributed gradient boosting library designed to be highly efficient, flexible, and portable. It implements machine learning algorithms under gradient boosting framework. So it encapsulates gradient boosting frameworks. XGBoost provides a parallel tree boosting known as GBDT or gradient boosting machine that solves many data science problems in a fast and accurate way. The same code runs on a major distributed environment like Hadoop and can solve problems beyond billions of examples. So you may want to look at the tutorials. Okay. Introduction to boosted trees. Read all this. No one is going to sit down and read all this. Uh, so read all this and see the mathematics behind everything. Then the tree boosting, also see the mathematics behind all this. So imagine this one was coded by someone. Yes, so but if you want to know the idea behind it, just come into their documentation. For us, we will use the the XGBoost extreme gradient boosting notes that I made. This one, how does it work? Is an ensemble learning method that combines the predictions of multiple weak learners or decision trees to create a strong learner. What did we say about? Remember, it encapsulates gradient boosting, and gradient boosting is each base learner is in the sequence is built to predict the residual errors of the model that predicted it. So XGBoost focuses on errors so that it can boost or correct those errors. And the only thing it's introducing while focusing on errors, it combines the predictions of multiple learners. Yes. Then it uses a gradient boosting descent optimization technique to minimize loss function, gradually improving the model's predictions. It adds new decision trees sequentially, just like a gradient boosting, while also trying to leverage gradient boosting to minimize loss function. With each tree learning from the errors of the previous one. So you see how it is basically an optimized gradient boosting technique. So when we come back, so when you have some time, please come here. and read more about this model. So let's see how it is implemented in Python. The parameters we need to use grid search CB to give us the best parameter. By the way, the best parameter for gradient boosting or learning rate to be 0.1, maximum depth to be 3, and number of estimators to be 100. For XGBoost, the same thing. You first of all note down the parameters as a dictionary. Notice the writing method, the dictionaries. Then after that, you use grid search CV to actually iterate through the dictionary to find the best matching parameters. Then we implement XGB classifier using the log loss to minimize the loss function. And we implement XGB parameters and such CV of 5 and scoring of accuracy, the scoring to be accuracy. So when we fit the model and find the best estimator, let's see. Okay, this is, I told you the warnings can be not. The best learning rate is 0.05, the maximum depth is 3, and the number of estimators to be 100, and accuracy was 80.41. What is the accuracy for the other one? AdaBoost 80.55. So AdaBoost works best. So, but if you may ask me, you can realize that they are more or less karibu zifanane. And because of data scientist preference for AdaBoost, uh, I think we may want to use gradient boosting. I mean, sorry, we may want to use XGBoost. And yeah, and I think the explanation in my cappuccino you are going to see. The fourth model is stacking. And what did we talk? What did we say about stacking? Yes, stacking, also known as generation, is an ensemble learning technique that combines multiple base learners with a meta learner to improve predictive performance. So it means we have multiple base learners, then we have a meta learner that is going to finish up on prediction. So as you can see, multiple, and they are different, by the way. Uh, the multiple base learners are different models. You can choose as many models as you may want. Then the meta learner is now like the logistic regression, a single model, but the other ones are actually different models. So let's see how it is implemented. Yes, first of all, look at this. We have three. It has decided to use uh, three base learners: decision tree classifier, gradient boosting classifier, and also the XGB classifier. So after doing that is when you implement stacking classifier. And stacking classifier basically gives you, I think this is the most direct one because we just know estimators, the parameters that you're going to implement there are a decision tree, XGBoost, and XGB classifier. By the way, you can even use support vector machine. That's your own preference as a data scientist. Then the final estimator that you're going to use is the logistic regression, which means this thing is going to implement what has been shown in this diagram. So model 1, decision tree. Model 2, gradient boosting. Model 3, XGBoost. Then the final predictor or meta learner, logistic regression. So it's as direct as that. Then the stack, you fit the stack model on X train scale and Y train. Then you predict. Once we do that and evaluate the accuracy is 0.7977, meaning at about ifiki. But one thing you notice that the values are not much far away from each other. Yeah, I think hata zifiki one zimeachana na 0 point something. Blending. What did we say about blending? More or less similar to stacking, except, yep. Uh, Again, multiple baselines are predicted to make prediction. That is what we said is a similarity. But the contrast, blending does not use a meta learner trained on whole lot population set. Instead, blending direct combines the predictions of the base learner on the training data to create new feature matrix. So let's see how this new feature matrix is created. So first of all, we have the following base learners, trained base models on training data, decision tree, and notice what is done. They're being trained independently. Like in stacking, they were combining in a stack model. Then, after being trained independently, what did we do? We generate predictions for meta learner. And that's what we said. We say that in blending, what it does, it creates a new feature matrix. And these new feature matrix are the generated predictions for meta learner. So as you can see, the X train in p dot column stack. Okay, you may want to come to NumPy and see what column stack does, but from the word stack, it combines different uh, features into columns. It stacks them into columns. Before the onset of AI, that's why those guys who came before us actually are very much skilled. We used to work with this, by the way, a lot. Still doing the nini, the searching. But basically, what it does, it combines all these. You see all these into columns. So this is a column, and this is a column for X train and both for X test metadata. Then after that, after forming a new feature, this is what we refer to as a new feature matrix. Then after forming the new feature matrix, that's where you train the meta learner. You see where it is being trained, the extend meta. You see on the predicted on the predicted results. Then after that, the Y prediction blending is meta learner to predict X test meta learner. When you evaluate that, it was 0.7821. Yeah, but you see all that information has been captured, or the information that we tried to explain here has been well captured. Yeah, voting. What did you say voting does? Voting is basically implementing different base learners. Then it uses a voting technique to choose which one had the highest. Yeah, so in voting, used for combining the predictions of multiple base learners to make a final decision or prediction. A simple and widely used method for both classification and regression. And here, multiple learners are trained independently, and their predictions are combined to make a final prediction using either hard voting, soft voting, or weighted voting. It is effective because it leverages the collective wisdom of multiple models, which can often lead to more robust and accurate predictions compared to any single model on its own. So it's commonly used in ensemble methods like random forest and bagging. So let's see how it has been implemented in this case. So voting model is the voting classifier, and see the estimators. The base models has been decided on to be a decision tree, gradient boosting classifier, and also the XGB classifier. Then the voting technique to be soft. Let's see what soft voting technique does as far as our notes yesterday were concerned. In classification tasks, instead of just counting votes, each base learner's prediction is assigned a probability score for each class. So the final prediction is then determined by leveraging these probability scores across all base learners and selecting the class with the highest average probability. So we are going to have the class of highest average probability among these classes. Then that is after fitting the model. So, and when we did that voting, notice the percentage for voting, and I think it's the highest percentage, even more than the XGBoost. So then, according to me, uh, I could have deployed either voting or XGBoost as a model on its own, and that's why we call it voting model. By the way, what these ensemble learning models do, they encapsulate, they borrow information from multiple models, to then use their own technique. You see, after borrowing the information, they use their own technique to make decision on how the results will be arrived at. By using, yes, that's what makes it a model. But now, to be specific, you call it an ensemble model, so that another data scientist knows that you have combined different models. In short, you've just combined different models using different techniques. In voting, what technique did we use? We used voting as a probability. Yeah. Information, there is a polymorphism has happened here. That is, information has been hidden from us because we've been given the result, but we've not known which model or base learner is actually the one that has scored the highest probability. Yeah, unfortunately, that is hidden from us, but the accuracy 0.8112 is derived from one of these using voting, and basically that's the probability. Then we have cascading. This one we said, and this is the last one. This one, basically, models were being built in hierarchy, where the output of one model is used as the input of another model in cascading manner, in stage, that is stage wise. So, and the only difference that we say it lies in is that in boosting we use mostly the same model in stage 1, stage 2, stage 3, all the way up to stage n. In cascading, you are allowed to use as different models as you may want. And that's the third point. Cascading can involve various types of models or algorithms at each stage, depending on the nature of the problem. So let's see. Stage 1, train a simple model, logistic regression to filter easy cases. So as you can see, it has trained logistic regression on stage 1, linear regression stage 1, and after that, we predict on extent scale for training hard cases. Then we've given a threshold of 0.8, which is a high confidence threshold. You are conversant with the value 0.8. Then you only single out those cases where the probability, the predicted values were less than the threshold. These are the ones that we want to optimize. The next one, choose another model, and in this case, we are choosing a XGB model classifier. So then again, for production on X-test scale, you can also predict and then choose the uh, then you choose the best predicted cases, which are the template literal. This something easy cases. Remember, the hard cases were the ones that were chosen to be less than threshold. So the easy cases are the ones that are greater than or equal to the threshold. So hard cases test mark can be evaluated to be more or less the same as, maybe that's how we may define it, the easy cases test mark. But we are going to see now. But the idea is, once you understood the fact that cascading, we implement models in stage wise, where you are given a room to implement different models, then you are good to go. That's why you see I was focusing more on actually ensuring that you get the theoretical knowledge of it. And you realize that if you get the theoretical knowledge, understanding the codes becomes very easy. Then initialize an array for final predictions on the test data. And these arrays are actually NP dot zeros. The predicted y, y values. What did we, you see, this is stage 1, then this is stage 2. So we want to have the final predictions. We initialize an array for final predictions on the test set. The test set is actually the one that we hid for testing purposes. Yeah, so NP dot zeros on the length of excess scaled data type is ytrain.d type. Then assign predictions for easy cases. Y prediction final on easy test mark, you predict using the excess scaled on the easy test mark. I don't want to renew you. Let me see. Then predict for hard cases using the second stage model. In P dot any value inside the hard test model. Uh, yeah, it makes sense. So I want you to focus on this, Sana. So I think for them, they have reached the second stage. So they are implementing predictions using the second stage, and the second stage was actually implemented using the XGB classifier. So, and the model was referred to as XGB stage 2. So we use XGB stage 2 to predict based on the excess scale, and we predict all the hard cases test mark. What information do we know of the hard cases test mark? You are below the threshold. That's it. Then maybe if you need some probabilities, the probability that we're talking about is we are borrowing idea from the voting here. So if you need some probabilities, the Y prediction probability final, we change everything into zeros. And period zeros actually say that we change just everything into zeros. That's what I'm struggling to understand. Maybe if you give me time to go and do more research. I do not want to explain what I'm struggling to understand there. So I'll start with that tomorrow. So meaning, let me leave this one the way it is, the cascading, so that I finish on it tomorrow. But at the end of the day, with all that effort, look at what we got. Yes. Well, it just this one it can happen. So let me also go and research on that. But it also depends on the model that you implemented as the baseline. I don't want to call it the baseline, but basically the first model in the sequence. Yeah, and that's why you see what they tried to do. They ensure that they trained a simple model first. Is when they went for a complex model. What if you did it the other way around? It means that our implementation could have started it at stage 1. Yeah, so to answer you, it basically the analytical scale of a data scientist. But let me go and research and see if we can also do a parameter tuning to know the number of stages. Now, voting classifier, when we now look at the voting classifier, the confusion matrix, prediction for churning out, not churning out to actually well predicted. And I think we've been seeing this most often. This one were well predicted. But there are some discrepancies. Look at this large number. The actual was yes, but predicted were no. So they were negative, meaning that they are false positives. Eh? True negatives, of course. True negatives, because the actual was yes, but predicted were no. False negative. Hmm? Eh, false positive. Yeah, false positive. Then we save the model for to be ready for deployment. You will see this once the right time comes. Okay, explanation for the Chan dataset. AdaBoost mechanics, we boost weak learners like shallow decision trees by weighing misclassified samples higher in subsequent iterations. We ought to explain how it focuses on hard to classify samples, improving recall for Chan. You must do hyperparameter tuning by adjusting n estimators and learning rate, and that's what we did. Then for gradient boosting, we build trees sequentially, minimizing a loss function, log loss, by adding corrective trees. We are teaching how to highlight gradient descent in tree space, balancing bias and variance. Adjusted n estimators. Basically, it's just explaining what I was explaining up there. So for your case, and by the way, after building all the data, make sure you request I send all these so that for your reference purposes. No, the data sets and the codes. We will push them to GitHub and use them for your case. You can share with the recruiter so that they can know, yes, you are building models and you are serious about it. Okay, and that marks the end of Ensemble learning as far as customer churn is concerned. So I just wanted as another added value, you want to look at churn dataset, a fraud dataset. And this one is now a more complex data scientist task in that we have two data sets which you have to combine. So your SQL merging technique or joining technique comes into play. So first of all, I created a new folder called Pro Data Set inside the I microservices. Then that's where I pulled all the information or copied all the data into. So we have this dataset CCF information info.csv and also transaction.csv. This data is very large, 21.87 MBs. So we want to see it while working with the data here. In this today's implementation, you've just been hired by a consultant firm called ABC Consultants. And ABC Consultants are working for Equity Bank Kenya Limited, where they're trying to implement a fraud detection technique for Equity Bank so that Equity Bank knows when a certain level of transaction is hit, this one is considered a fraud. That's how they need. Like they look at outliers actually. Simply put, they look at outliers. So we import the following, and I did this with Ensemble, and let us put our main focus on XGBoost classifier because that's the best one that's always used. Of course, huko mbele tutapata artificial neural networks being used, but for now, let us work with XGBoost classifier. Nowadays, companies have run into deep learning a lot, so they are implementing artificial neural networks. But that one does not mean that XGB classifier has been like we've done away with it. I told you when it comes to building models and deploying on production, do it, monitor. If it works, leave it. Yeah, so don't say, oh, nowadays they use artificial neural networks, we cannot use XGB classifier. Why is it there if it cannot be used? So we import all the required dependencies and libraries, and of most importance is the XGB classifier, and that's where I'm going to put my much focus on, especially after importing, merging, and doing pre-processing. So I imported two data sets, transaction DF and credit card information data frame. So CCF means credit card info, credit card. I think I ought to explain here so that you not wonder. So if you look at the transaction df dot head, it has the credit card, the date of the transaction, the amount that was transacted in that day, and the longitude or the region where the transaction happened. These are the things that we capture when using online transaction, so that we know people from different areas. At the end of the day, just for to make humor, at the end of the day, Kisumu will win. Hey, my people. Then we also look at the credit card in df.head. The credit card information has the credit card number. This the name of this nini inaitwangaje? The name of this number. The one that is always in the credit card number, that one. So look at that credit card, then the city where the credit card was uh, given, and also the state, the zip code, and the credit card limit. When your credit card has a limit of $6,000, we want to see how much you transacted. At the end of the day, we need to combine the information from the transaction DF. This transaction, credit card information is available by the banks. Transaction, they're waiting for it to happen. Once it happens, it's combined with credit card information so that we produce one large data set that has the credit card information and transaction. So after that, we can start performing fraud detection. So let's see how fraud detection is done using Python. Number one, we merge the data sets just like I promised. First of all, you need to identify which one will be the in the star schema, which one will be the fact table. Okay, basically think of it, nope, think of it as which is our data of interest. Yes, transaction is our data of interest, yeah, because that's what we want to be to see. Actually, the best, you see this column called transaction dollar amount, longitude, latitude. These are the information that we really need. And also maybe to a larger extent date, because someone can on in that date we can sum up and see how much were transacted. Let me deviate you from this to market share. When you come to market share, let's say people start transacting on market share site, and in a day you are able to see how much someone transacted by using SQL sum. This is what it was done. You know, in a day inamaanisha I can buy something in the morning, in the afternoon ni buy ingine, hata usiku ni buy. And look at the date. The date also has time, so you also know when this happened. So probably we may use the last time. For example, kama nilibuy kitu asubuhi, mchana na jioni na usiku 9 p.m. So the time that will be indicated is 9 p.m. But the amount is sum of that day. So so we want to see who actually, what is the anomaly detection here. This is basically, you can call it fraud or anomaly detection, it still works. We want to see what were the abnormal transactions that happened this day from a credit card, and in what longitude, because even if you took it in Dallas, you can still go and transact in Washington DC. Yeah, so we would look at, and where was this credit card given? Why did he rush all the way to Washington to withdraw funds? These are the things. The limit. How comes in a day the limit is $18,000 and someone is transacting $17,500? Kuna kitu hapa. So that's the anomaly we want to see. So using this information, we merge. And uh, we merge, wait, transactions df.merge, credit card information, how left. We merge transaction df on credit card information. No, no, no. On is the new that we merge on the column. The oh, what do we call it in SQL? The primary key. Yeah, the primary key. But we can you can see this guy transacted this day. Again, I can transact this day. I can transact this day. So maybe the only thing that might be the only thing that might be unique, maybe date. Never know. No, no, no. Credit card is not unique. I mean, by unique, I mean the one that can be used as primary key. Primary key means that it should not repeat itself. So you see, this one has repeated itself. It's not unique. So for transactions DF, credit card cannot be the primary key, but it is going to be the foreign key to credit card info, whose primary key is the credit card column now. So you see, before you start analyzing data set, you must ensure you understand your data set fully. Yeah, and that's why we taught lots of schema and data modeling in Python. In your CV, you can do this modeled data and merging data sets, combining data sets, and so something like that, ensuring. And it's true you did it, except that people add a lot of spices there. One thing I learned from Tech Savannah, I have to be honest. By the way, it's a very cool workplace. I have to give credit where due, because the decision sometimes might be rushed though. But one thing I love about them, they hire they hire based on merit. Your CV can speak lots of spices, can have lots of spices the way you want to add them. Keep they're waiting for you. Those guys who add lots of spices, they told me research, find as difficult questions as you may look for, like around you research on those questions so that during that day we see if what he was trying to explain in his CV matches what is in the brain. At the end of the day, you end up failing because maybe you lied. So, in short, why am I saying all this? Don't lie on your CV, just be moderate. If you did it, say, like in this case, we are going to say completed certificate in machine learning engineering from MarketShed. It was able to deploy and do everything to model data, pre-process it, and to make it authentic, find the projects here. Then you give the link of GitHub where the project resides. The day of evaluating your application, I just come and click on the link, go to your Nini, see. And even because the senior data science does that, I will even scroll through and see and say, okay, this one might be a better fit. Let's try him. Let's see if what is here is actually in the brain also. Then yeah, that's it. That's how you now win. Hmm. Yes, you can see the merged underscore dot head, and I was going to do that. Why should we anyway? Oh, it's standing. Let me interrupt and see. Restart. Restart. Maybe, but I don't know. I don't know. Let me see. There might be something. Nione huku mwisho. Oh, the problem was this one. Keyboard has been interrupted. So it was actually training a model huko chini. Eh, does it want to tell me it trained the model in 62 minutes? What's not the problem? So let me start running it one after the other. There's a problem somewhere because this one should not take this long. There's a problem. Aye. And what is that is importing? Okay. It's my internet, maybe. So this is the data set. Remember, we left join. We left join transactions and in credit card information onto transactions using left join and using the column credit card. Yep. And you can as well go ahead and see. That shape. 294, 588, and 9 rows. So fish engineering. You can as well look at other things like Control B. Oh, yeah, Control B. E. Oh, just B, not Control B. Shit. To open another cell. So you are able to see also other information like, or you can as well go ahead and describe. The mean transaction dollar amount. The column we are interested in is here. Then the maximum was $99, $9.99, around almost 1,000. The minimum was 0.01. You see, these minimums you are more interested in because this $1 by the 1 shilling, 1 Kenya shilling, you might be interested in knowing this 1 Kenya shilling. What happened? Like, why was this guy transacting 1 Kenya shilling? Maybe a hacker worked account so that 1 Kenya shilling should go into his account each and every time. So these are outliers which you should look at. You should also look at the longitude and latitude, the zip code, and the credit card limit. The credit card limit, the average is the maximum credit card limit for a person is $55,000. That's around 60 million plus in Kenya shilling. Then the minimum is $2,000. So these are the information that we are interested in. So we go with the feature engineering. Now, for feature engineering, this is a very important and critical task. First of all, you must just come here and ensure that all the data points, or the features are exactly what is depicted by the df.info. The credit card is integer. The date is an object, which should be date time. Transaction dollar amount is float. Latitude, longitude, city, object, zip code, integer. Credit card limit, integer. So let's see. First of all, the MyDF of date. This is basically to single out a column using, it's called indexing a column using the square brackets. So pandas to date time, merge df date. So it's changing the date to date time. And you're going to see after doing that, merge df dot info, fresh one, so that you can see. You see now it's date time. It has been changed successfully. I merge df hour is equals to merge df date dot dt dot hour. This one is pulling out, is disintegrating hour and date, like it's separating date hour from date. Yes, it's separating hour from date. There were hours in that the same date here. Yes. So yeah, so it's pulling it out, and that one should be stored as merge df hour. Then we also have merge df day of week, dt day of week. From the date, you are able to do that. This is called date transactions. The date time model, the date time, if you come to its documentation, it has all those information. Day of week, dt dot time, everything. You just find it here. If we continue, then merge df amount to limit ratio is transaction amount to limit ratio. This is basically, you are going to see what the transaction that someone did to as compared to the credit card limit. So that's why it is being, we are dividing it. Then the median location, you group by the credit card and latitude and longitude. Then we find the median location, like the location that might be centrally placed as far as transaction is concerned. Of course, the F dot, the Scribe also gave it at, I think at 50%. So the location is what, -73 longitude and 42 latitude. All that information. Then you merge df, you also merge the median locations. On credit card, suffixes is an empty one. So this one was actually a sub data set that was pulled out from the longer data set. And you see reset index, meaning that you put them in indexing format. Then you also have merge df distance is equals to np dot square root. This distance, why are we calculating all this, by the way? You know, before you do a big thing, you must understand your data set. Let's go back. Let me take you back a little. Look at this data set here. This data set has credit card, date, transaction dollar amount, longitude, latitude, city, state, zip code, credit card limit. We've not been told of anything called fraud. So it is us to try and engineer this fraud thing based on our analytical mindset, what we may understand of fraud. So the analytical skills that you may have here will tell you that if there are some calculations or some transaction amount which we feel like are too small or too large, like outliers, or too frequent, then these are what we can refer to as fraud. Are we together? So that's why we are interested in engineering all these features here. So at the end of the day, you see the new merge DF is having lots of columns, and I wish to have Nini showed it here. Dot head 5. So you see date, transaction longitude, latitude, day, city, zip code, then hour that the transaction happened, day of the week, the fourth day of the week, the amount to limit ratio is 0.02. We just want to see if this amount to limit ratio is too small, too negligible, then we have to raise question. Then the longitude and the latitude. I am more focused on engineering this distance because this is the one that is going to help us a lot. You are going to see how. Now, the distance is actually gotten as the square root of, but let us still not focus on this. See this. We have a longitude and the median of the longitude. The median of the longitude is actually the centrally placed value in longitudes. So each and every longitude will have that. Each and every longitude, longitude, how far is it from the median? And probably median, because it is always or almost equals to average. Zinakwanga almost. Even if you look at the describe, now see the importance of descriptive statistics. Look at the longitude, negative 76, and 50, negative 23. Hazitawahi achana. But now when you look at this and square it, it's basically doing away with, to square is just to do away with nini. The formula, to do away with the negative sign that may. The formula for find residuals, you remember what we said, y minus then squared. So in this case, we are saying longitude minus longitude median squared plus also latitude minus latitude median squared. Then if we were to find the standard deviation, which is the distance between a data point and the mean, we were finding the square root. So this scale here is what we've just borrowed, and we are using it in finding the distance. And why are we finding this distance? Let us just move for the poly. We are going to see. Then suffixes we are joining. You see longitude. If the name is longitude, we are joining it with median. Latitude we are appending median to it. So at the end of the day, it will be called longitude underscore median. This is what this suffix means. So at the end of the day, that's what we've calculated, how we've calculated distance. So let's see the distance. Again, we can go ahead and calculate a new describe merge df. The minimum distance. The minimum distance is 0.00. It doesn't exist. That is, and the maximum distance is 338. And the median distance, if you want to know there is an outlier, let's see the median. The 50th distance is, look at this, 0.06. So first of all, we've marked this. Yeah, we've marked that. Then we also have something one that is mean. The mean distance is 1.9. There's no way a mean distance is 1.9, then the maximum becomes 338. Let's see. Now we synthesize a fraud label. That means we want to identify frauds using our analytical skills. So it might not be perfect, but at the end of the day, that's what we are interested in. So the MyDF fraud, a new column called fraud, is the MyDF distance if greater than MyDF distance of quantile 0.95, meaning all those distances that are greater than distance that falls 0% to 95%. I don't know how I can explain this usually, but what I'm trying to explain is that you see this is 75%, Cindy. 75% percentile, that is the 75 percentile, the other name for 75 percentile in statistics. We looked at this in statistics for data science. Look at this, the third quartile, yeah, thank you. So that's 0.0780759. So it means we are looking at the 95th or 95th percentile. The 95th percentile should also be something less than 1 based on the trend of our data set. But now we are saying if there is any distance that is greater than that, then that is a fraud. Yes, that's a fraud. And now that's what we say. Now see, also account to limit ratio is 0.5. Let's see why the choice of 0.5. We go to account to limit ratio. Amount to limit ratio. Let's look at the mean first of all. The average for of all the transaction in our data set is 0.0066. That is 6.66 raised power negative 03. 0.0066. The maximum account to limit ratio that ever happened was 0.049. So, and the minimum, basically the minimum was, just take your time in analyzing the data set, don't rush. 0.0000285. We've known that. So we are looking at that. It means that we are looking at OR. This one means OR. If the distance is greater than 0.95 or the amount to limit ratio is greater than 0.5, then that one is a fraud. Yeah, that's a fraud. So we synthesize now let's relook again at MatchDF. Dot head at 5. Run. Yes. Where is it? It could have created. Nafaa kwa imecreate ama sija run. Oh, sikuwa nime run. Should create. Yes, so this is not a fraud, this is not a fraud, this is not a fraud, this is not a fraud. Maybe we can look at value counts of each and every fraud. So merge df into fraud dot value counts. There were 14,730 frauds and 279 815, according to our analytical skills. Having known that, we now start looking at the categorical features which we might use. In fact, now we can again go ahead and merge df. Tutasonga tu na hii merge df.4 mpaka tumalize. Integer, we have credit card integer, date time, transaction dollar amount float, city object, state object. But remember, the machine learning do not work with objects, so we change them to nini. We change them to numericals. And how do we do that? The only way we can do that is by leveraging the nini technique, the dummy get dummies technique. By the way, the get dummies, this is how it works. For example, if you look at the city, I think I've been explaining this ever since. If you look at the city of Houston, I don't know if that's how it's. Then we also have Pennsylvania, the state of Pennsylvania. So these two, the get dummy is going to recreate it such that the dummy is state underscore Pennsylvania. So the column name will be this. So if it is a state of Pennsylvania, it will be given 1. If it is not, it will be 0. Are we together? Same thing with the city. The same thing with the city. City will also be given the same thing. So city, that is get dummies, how it works. House. If it is Austin, acha tu niandike so that you know. Yes, if Austin or 1. But basically in data science, yes, 1, true, are evaluated to one thing. 0 if not, like that. So that's how get dummies work. So you ought to have known that. Okay, so we encode categorical features. First of all, you have to identify which are the categorical features, the city and the state. So period to get dummies from the merge df, and columns that we are getting dummies of are only city and state. Then drop the first one is equals to true, meaning we are only going to remain with another state. But let me see. Let me see. Values.unique. Merge df city dot unique. Yep, that's it. And these are the cities: Austin, Washington. So if we look at the Austin, then it means that others will be taken as 0, and Austin will be considered 1. The same thing will be done for Washington, Charlotte, all the way up to State Island. So we are going to do that. The same thing, even if it's also state. Let's see the state. We have the Pennsylvania all the way up to Utah and also the Los Angeles. So all these are going to be encoded such that when we have a state of Pennsylvania, it's going to be state underscore Pennsylvania 0, and others will be as 1, others will be given 0. The same thing we move to this one. I don't know if it's, I don't know which state is that. All the way up to Utah. So Arizona and Utah. So all at the end of the day, the dummies will work when we drop first. That's how dummies work. So the merged PDF is equals to, we drop the credit card. Next, we drop the columns that we may feel are not needed in our analysis. I don't think if we need credit card because we've used it. The debt we do not use. We need, how can you drop that? You cannot. We need longitude, we need latitude, we need the city, so that we can know where that person alikuwa anafanyia nini yake, anomaly yake. We need the state, and now you see how DCI picks people who robs the bank. You need the zip code. I don't know if the zip code. I don't know, feel if we need it. Personally, I could have just the latitude which is needed, basically to know your exact location. Latitude, longitude median, and latitude median are all not needed because first of all, kwanza, see, it's basically the one in actually a single value. So we do not need them, and we drop all that. So once we've dropped all that, we can now continue to split our data set. Cleaning data set. You see how hard it is. And remember, in this case, tuko na moja. What if we were to form a star schema which was to have 3 or 4 data sets? So we have data set here, 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 here. You are supposed to engineer features, clean the data set. This is what I advise. When you are working, right now we are learning just to showcase your skills. But when you are working on a real world data set, I highly advise, if you don't understand anything, just rush to YouTube. It is always our next single source of truth. Yeah, personally, I used to keep aside everything I was doing, open a YouTube video, watch, ensure I see how data is. If, for example, if I'm having a problem in combining data set, 4 data sets in Python, I just go and watch that, then implement with mine. At the end of the day, I'll build a very robust machine learning model, because if you find it wrong here, you're going to find it wrong everywhere until we are done. Now we split the data set. Remember, after dropping credit card, date, longitude, and latitude, tumebakisha all the other columns, including fraud. But fraud is the Y variable, the target variable. So we remove it from the MyDF and assign it to a variable called X fraud. So meaning this is the X variable, the independent variables now. And the dependent variable will be the fraud itself. And then after that, we split the data set, then scale it, and after that we transform it. The next thing that follows standard scaler is always to fit transform X train and transform X test. So I implore you to visit the single source of truth sklearn documentation. Having done that, we can now start implementing AdaBoost. Implementation is basically the same way we were implementing in the other in CAN, because at the end of the day, we just want to see if it is fraud or not. Aya, sasa run this and then run this. Yep, and it depends on the number of dimensions that your fact table is going to have. So if you thought this knowledge was ending in SQL, you are wrong. You are wrong. Yeah, and actually now in software engineering, it's even worse. So ability to model and understand data scheme, the data, to understand table schemas and everything. I think if one day I'm hiring for a data analyst role, that's something I must include in job description. So this is the guy who took lots of the time. So it's still running. I once implement it, you are going to see the accuracy score. Then implement gradient boosting. For gradient boosting, I am not going to explain this because it's like exactly what we are doing the other side. It's just that now we want to see the ones that have been considered fraud or not. Then XGBoost, then stacking. And then you look at the confusion matrix for XGBoost. Then when you are, by the way, I saw somewhere it was, the value was 1, like 100%. So it was that accurate. So I was so much drawn back and was like, no, it can't be. But at the end of the day, nikakumbuka the data was synthesized, so it might be true. Yeah. So based on your uh, grid search thing or everything that is happening here, this one might take a lot of time. So we cannot wait for it. But I just wanted to show you how a fraud can happen. Once you got an accuracy, let's say of 90 and above percent, you can deploy this model so that you see, the new information that comes in here, the new information that comes into this data set automatically is going to pick up on this model and will be classified accordingly. So the front end software engineers will have a software in the front end which shows the admin or the data analyst team what has transpired. Maybe it will be developed with a disclaimer: check this account, it might be fraudulent. Yeah. Every day I know your mind opens up and you're like, okay, so this is what happens. Yeah, this is what makes our accounts swell. By the way, I tell you, there is no high paying job other than machine learning. It's just that we've never been lucky to find the best employers. But the fact remains, data science or machine learning is the highest paying tech job. Okay, this is where that has run. Ah, you may run, sure. Sorry, guy, that it has run English. Then you see the number of estimators, the accuracy is 100%. I saw it. Yeah. Okay, the gradient boosting, you can also train that. You see, the reason why it took time is because it was trying to find the best one using grid search. 50, 0.1, 50, 1, 100, 0.1, 100, 1. What I don't know if it goes between 0.1 and 10, but I don't think, otherwise we could have said range. Yep. So I think this is it. This is what we wanted to see. I go to Kaggle, get data sets, build as many banking fraud detection, talk about it on LinkedIn, push to GitHub, and everything will be okay for you. But you chose the best field. It's just that people have never been lucky. If personally, if I was in US right now, I could be driving. That's honesty. I'm honest about that. Now, it also depends in the country where you are born anyway. Yes, but again, I hope by the time you're done with deep learning, you would have taken a step. But again, right now you are also seeing yourself as someone who's taking step by step. But let us not stop at where we are. Always take time on your own and build models, as many models as you can. Use many data sets. If you want to work at Jumia, pull the data set from Jumia website, web scraping. Pull the data set from the website, analyze, talk about it. But it's very risky. I told you the other time. Or you can find an e-commerce data set from Cargo, analyze it. After analyzing it, talk about it on GitHub. Find recruiters online via LinkedIn. Then at the end of the but if you find a recruiter, try as if you want to answer a problem for them. I built this model which can do this and this. For example, in this banking one, we can tell Equity Bank, we built this model which can help you identify fraudulent transactions. So at the end of the day, maybe kindly schedule a meeting and talk about it. Unaitwa kwa meeting kwa boardroom. If it is kurambwa, utarambwa. Kama ni kupata, utapata. 0 or 1. Yeah, I was trying to bring stories so that this one runs, but unfortunately, at least we found one with AdaBoost. So I wanted one with the XGBoost and this, but okay, let me just leave it to run. But that marks the end of our supervised learning technique. I never knew I was going to finish it today, but I hope you've gotten the concepts. Yeah. Okay. So we can stop there and meet next week because we are done with supervised. I'm giving you time to implement what we've done. As you saw on our WhatsApp group, I sent the links. So the only one remaining is the current one, the one we are finishing up on. You will also find it. So after it has run successfully, I'll send. No, no, I need to send you the data sets because they are actually the actual data sets. And thank you for the reminder. Ah, so we meet on next week on Monday. And sure, please, you at least build two models by Monday. Okay. Thank you for joining this week's class. Let's see each other on Monday. Then also, I'm told ulitumiwa email ingine. Hata ananikumbusha hapa nyuma yangu. Yeah, okay. Sawa sawa. Thank you.